Thanks very much, Jay, for that very generous introduction. And I'd like to thank Jay Vishwanathan, Vridita, the TIE, the ICC, and the Pan-IIT for hosting this event, which Jay took so much initiative to bring about. So I'm really delighted to be here. This last hour, talking to so many of you itself gave me the energy that this is, I mean, this is exactly what I wanted to come here to feel the energy in the Bay Area among so many of you, and that desire to want to channelize the energy into something impactful. So I will talk about this question which Jay said, make it provocative, make it this thing. So definitely it's a very pressing question, and many of you have, of course, said this is something that you have always also thought about. I'll offer my sort of 2 pennies of thoughts on this, but more perhaps importantly, I'd like to suggest a concrete pathway to take us some way towards addressing this question. It's a sort of, and I think it's something that one will have to address collectively at some level, but it is perhaps not as impossible as changing the many different problems that are contributing to this issue, but I'll try to address a concrete pathway in which we can try to make some headway towards this. So the basic message is it's not all gloom and doom. No, it's not like we cannot produce. Yes, we can, and so let's try to see how to do that. So this is ICTS-TIFR, the newly built center which I am from, and so that ray of hope over there is supposed to be not just metaphorical, but it's supposed to be that perhaps we can try to make progress with an institution like ICTS, and I'll outline how. So let's just step back a little. So India, of course, one of the great things is, especially since independence, we've had a national commitment to science and technology, which is why, of course, so many of us have been to the excellent institutions of the IITs and other such institutions for both engineering and science. And these have been set up with public money, and there are research institutions. The IISc, of course, is one of the oldest in the country, TIFR, of which ICTS is one of its newest centers, is another, the CSIR lab. So there have been a lot of research institutes in India. But if you look at the pantheon of Indian science, there are, of course, all the names that you're all familiar with. Maybe some of you may not know G.N. Ramachandran, who is a very distinguished biologist. In fact, he's one of the people who made several contributions, who should have, in some ways, perhaps gotten the Nobel Prize in biology, but somehow didn't. But one thing you will notice is all these pictures are black and white pictures. So this is from an era of before independence, mainly. G.N. Ramachandran's work was in the early 50s. So it's a little bit sad in some sense, but it's not that we haven't had successes in recent years. I'll just name a few just to sort of, again, highlight some of the positive stories. In mathematics, a very fundamental discovery by M.S. Narasimhan and C.S. Seshadri, 1965. Ashok Sen's work in string theory made a real impact in the field and drove whole developments for a decade or so. In 1994, many of you have heard of the work of the people Manindra Agarwal, Neeraj Kyle, and success.
Speak the name because of the light we cannot see anything.
Oh, I'm sorry about that. Is there a way to? I guess we can't switch off some of the lights, no? I see. Okay, so this is Narasimhan and Sheshadri. Is it visible at the back or? It is? Okay. So the AKS primality test of whether a number is a prime or not, that was again a path-breaking work in computer science in 2002. More recently in the LIGO collaboration, which discovered the gravitational waves in 2015, which you might have heard of. There were groups in India, in ICTS, in IUCA, in Pune. This is the Inter-University Center for Astronomy and Astrophysics in Pune. These had major roles to play in the LIGO discovery and analysis, and I'll say something about that later. But there have been some very impactful contributions, but it's only a handful, and in many ways, you will agree that it's not commensurate to our population and the sheer talent that we have in India. And I would say, in a way, it relies a lot on what's called the occurrence of black swans, which you might have heard of this black swan theory, but which these are rare events which will happen in a large population, and but you cannot rely on rare events, and certainly a country like India cannot rely on rare events to take you through the 21st century. What you need is to cultivate systematically excellence, which is what will ultimately nurture the kind of breakthroughs that lead to Nobel Prizes or Fields Medals or Turing Awards or several of the highest scientific awards in the world. So the question, in a sense, is how do we address this? And in a way, a measure of this is some facts which are actually there in a very interesting chapter in the most recent Economic Survey of India. So if you go and look up the web page of the Economic Survey of India, which is brought out just before the budget every year in February. So this year, February, the Chief Economic Advisor, Arvind Subramaniam, and his team, they brought out their usual, it's like a State of the Union Economic Survey. And it has, for the first time, a chapter on science and technology. That's actually quite unusual, that it had a chapter, and it's a very insightful chapter which has a lot of useful figures and data about the science funding and the state of science in many ways. So I just want to share some of the figures there, just because it conveys an important message. So this is on this side is the percentage of the GDP for R&D. Again, and this axis is what's sometimes called the development time, which is an interesting concept, which is basically plotting your GDP purchasing parity power on this axis in some log scale. So it's basically telling you that when a country had a certain purchasing power parity, so if you take that as a measure of development, how much it was spending on R&D. And maybe the colors are not very visible, but this curve over here is India, and that's sort of what has been extrapolated over here. This curve is the US. This one is China, and it's gone here, and this is Israel, and this is South Korea, and so on. But one of the interesting things you see between India and China is that for a long time they were almost the same, the purchasing at the same level of development, they were spending almost the same. In fact, India was spending a little more than China. China had this big dip here. So India was spending a little more, but in recent years that's sort of gone down, whereas China has steadily increased, and now it's somewhere up there. So their purchasing power parity right now is there, and they're spending about 2% of their GDP. India is spending about 0.7% of its GDP on this. So you see the trend, and you can measure it in many different ways. So that's the spending, and the output naturally also is correlated. If you look at the number of patents per million against the same developing time, this is the curve for India, this is the curve for China. So we are, and this is a logarithmic scale, so in a sense we are very much order of magnitude below many of these countries, let alone the ones of India, of Israel and Japan and Korea. Anyhow, if you want to see more of this, I would recommend going to the CEA website. This is about the publication output. Once again, you can see it compares, this may not be visible, China, India, United States. If you compare the total number of papers in 1990, 2001, 2011, you can see in China it's a huge growth from 6,000 to 122,000, whereas in India it's 12,000 to 36,000. And in fact, the number of highly cited papers, which is perhaps a better impact, better measure of the impact, goes from 174 in 2001 for China to nearly 1,000. So it's almost like a factor of 6 or so. Whereas in India it's from 100 to 191. So, and for comparison, in the US it's about 3,000. So you can see the sort of the big gap between output as measured, impact as measured on the world stage with respect to science, and of course it's directly correlated with the spending for science as well. So these are the facts, and so you can so putting all this together. So what's really lacking? Of course, resources, as I just mentioned. And so there's a sort of a missing ethos, I think, in India of long-term investment in science, because science is ultimately a long-term investment. You do not see the returns in 5 years or the election cycle that drives most politics. And besides, there's a sort of a self-fulfilling trap here in which you feel that you're not getting enough returns, so you invest less. So of course you will get even less returns, and that's why the percentage of spending in India has been going down. And it's sort of self-fulfilling. Then you feel that you're not getting anything much out of science. What's the point in investing? But you see, on the other hand, in countries like Israel, it sort of goes the other way, because you feel you're getting more returns, so you invest more, and then you get even more, and so it's a kind of a positive feedback over there, whereas here we are stuck in a sort of a negative feedback cycle. There are many other factors, and I'm sure all of you have also things to add to this, but I just listed a few, like the subcritical number of researchers at any institution. So we have a number of institutions, we have some excellent people there, but they're often scattered and don't form the sort of critical mass necessary to really catalyze excellence. Often there is, there's a lack of confidence or ambition to even, I think the system in India of the institutions doesn't often generate in people the ambition to do big things. It's much more, there's a safe option of doing something at a very basic level and not trying for something very ambitious, which can fail, of course, as you know. And this is something which China, for instance, is not scared of taking on big challenges, which I think collectively they have decided that that's something that they can do, and they have the confidence to deliver. So this is definitely, I think, a psychological inhibition that we need to overcome. Countries like Israel, I'm just messing this up. Countries like Israel have, I think, are models on how the diaspora engages with the institutions in Israel, and this is something I feel here in this audience it might have a resonance, because again, I think there aren't very good channels for the engagement of the diaspora, and they can, and I'm sure all of you can engage in many different ways to have an impact, and we can talk about that later. Finally, there are few knowledge pipelines between industry and academia, which is again a source of enrichment on both sides. Industry, that's how knowledge gets transmitted, and applications of the cutting edge developments in science get translated into technology. So this is something that has been, of course, the Bay Area is a very good example of that, and Japan, Korea, and other countries have also have perfected this in many ways. But in India, there's almost total disconnect. So just the absence of these pipelines is I think, an inhibitor. So then, of course, in the face of all this, you can ask what is to be done. So there's one attitude, and I think it's a natural attitude. You might think, oh, this problem is so big that whatever I do will not have any impact. Whatever I do, there's systemic changes that need to be done. We need to address much more resources. But I'm not the finance minister. I'm not allocating the budget for science. So how can you address this? Similarly, you need to have many more world-class institutions. But how am I going to be able to address that? So so you might get paralyzed into doing nothing because you think that everything needs to change. But I think that's not necessary, and that can sort of unduly paralyze you. I think it's important to dream big, to have those grand ambitions. But at the same time, one has to be somewhat tethered to the reality, which is India, and all its complex dynamics. So, but within that, find a sort of a pathway which can make an impact. And so in my opinion, I feel there is such a pathway, and I'll try to outline the elements of that. But it basically consists in investing in really high-level excellence, which in some sense has been happening. The IITs and other such institutions are examples of that. Instead of trying to address the problem of having 100 high-level institutions, I think it was very wise that 4 or 5, at least in the initial years, 4 or 5 IITs were chosen as places of excellence, and that has definitely had a disproportionate effect. I think it should be carried to its logical conclusion in the sense that you should have more institutions which sort of distill excellence, and that can catalyze a change, much like perhaps many of you may recall from your chemistry how small elements of something like platinum are very essential sometimes for just triggering a much bigger chemical reaction. And I think excellence really by itself can do that. And that's what we need if you want to multiply all these scattered successes that I mentioned in the beginning into a systematic cascade of breakthroughs. You want something which will generate in a more reliable way breakthroughs as some of the other scientific, advanced scientific nations have been doing. I think to have this in India, we need to put in place this mechanism. So let me try to outline how, by taking a small digression into a concept which may not be so familiar to many of you, but which I think has played a very important role, certainly in the United States, and more recently other countries have also adopted this. It's what I would call science aggregators, because to just continue that analogy with the chemical reaction, like in any chemical reaction, you need to bring together all the reactants. So you need to bring researchers together for long periods, and that's what triggers new ideas. And face-to-face interactions, even in today's virtual connected world, are in the end indispensable. I think you go out for dinner, you chat late into the night when you're together, and that's how the best ideas are born. And the kind of dynamics that drives scientific inventiveness, I would sort of encapsulate as criticize, compete, and then collaborate. Because that's often how individual scientists, when they are together, you initially challenge someone's ideas, then you sort of compete to try to come up with a better one, and then you often join forces. I mean, this is, of course, true in many spheres of human interaction, but in science, that's one of the major fuels that drives inventiveness. And what's often lacking in India is basically because of the subcritical numbers, you don't have that reaction, cross-section, as they say in chemistry. And there are successful models of such international science hubs, which aggregate people. I mean, aggregation is now, of course, something all of us are familiar with, Uber and so on, the effectiveness of aggregation. But in some sense, in science, this has already been playing a role for several decades now. In a way, the oldest such institution is the Institute for Advanced Study at Princeton, and I'll say more of that in the next slide. But closer to here is the MSRI, which is in Berkeley. The Mathematical Sciences Research Center in Santa Barbara is the Kavli Institute for Theoretical Physics. So these have been hubs for maths and physics and have played a very major role in their subjects. And the Institute for Advanced Study, of course, is something which many of you are probably familiar with. It exemplifies the enormous benefits of concentrating excellence in a single place, and to this aggregation. For instance, it's a small institution. Many of you may not know that it has never had more than 15 or 20 faculty, more recent times in the sciences, more recent times in mathematics and physics and computer science. It has maybe about 15 permanent faculty, but a large number of visitors and members and so on, and it has had a disproportionate influence for that kind of a size. There have been 33 Nobel laureates, 41 out of the 56 Fields medalists, which is the equivalent of the Nobel Prize in mathematics, and more recently the Abel Prize, which is given in mathematics by the Norwegian government, which is sort of gaining the stature of a Nobel Prize in mathematics. The 17 out of the 19 Abel laureates have had affiliations with the Institute for Advanced Study. All of you recognize Einstein. Von Neumann built the first digital computer. The first computer was more an analog computer, ENIAC, at the Institute for Advanced Study. This, perhaps many of you may not know, is Harish Chandra, the only Indian a person of Indian origin to have been a permanent member at the Institute of Advanced Study, and probably the most significant Indian mathematician after Ramanujan. But he spent all his working life in Princeton. And this is Avi Vigdason, the computer scientist, Ed Witten, string theorist. So it's an incredible institution, and having spent extended period of time there, I can testify to that kind of energy that comes there. And similarly, the KITP and MSRI, as hubs in physics and maths, have had programs which have had a big influence in the subject, because typically all the experts in a subject gather there. They are there for an extended period, and out of that interaction come out, wonderful ideas come out. So this is a certain aspect, the aggregation, but these institutions play a different role, which is also very important and not very usually appreciated, which is about knowledge curation, what I call knowledge curation. Because there's a whole lot of stuff over there, and all of you know you can be overwhelmed if you just search some keyword in Google. You'll find like tons of pages. But what are the likely ingredients for the next breakthrough? It's not very easy for even practicing scientists in a given area to sort of figure out what are the areas which are more promising, where you can make progress, which is sort of a thrust area. So knowledge, in some sense, needs to be curated, distilled, and transmitted to be effective. And the process of doing that is often best done by the best researchers in the subject, who often have, in a collective way, often have a sense for how the field is progressing, what are the areas that you can make breakthroughs in. So this knowledge curation is something that I think these institutes do very well. The programs that are organized at the Institute for Advanced Study and so on send a message to the whole community. Yeah, here this is a program, this is a topic in which we are able to make progress, and you see it in the output, the scientific output from the community. And now many countries, including China, Israel, and Europe, and Canada, etc., have all sort of have these hubs which perform this role. Another role that these play is what I would call, in a very long word, which I'm not even sure is a word in the dictionary, decompartmentalization, which is programs which cut across disciplines. As perhaps many of you are aware, I mean, the traditional sort of silos in which you have scientific research, biology, physics, maths, computer science, and their interactions with engineering, medicine, or technology. It's not very sharp. I mean, these are silos we create, but nature is not pigeonholed into any of these silos, and very often the interesting stuff happens at the boundaries of these subjects. So this is a role that these knowledge these sort of science aggregators or these science hubs play, which is to bring people from different disciplines together. So, for instance, a machine learning program, in a sense, needs to, with neuroscientists and physicists and computer scientists and mathematicians, brings a number of perspectives, which is the kind of thing that really leads to a new spark, to breakthroughs in the subject. And this is a role that traditional universities don't play very well. I mean, though they have been trying through various interdisciplinary centers, but these science hubs can be very effective in doing so. So, and finally, by bringing together the abstract in all these disciplines, there's a core which is perhaps not immediately. It's not immediately obvious how that would lead to something tangible or have a concrete spin-off. So it's often in biology or mathematics or computer science, you might think that the frontier questions are very abstract, but remarkably, and this has been true in history, these very seemingly abstract things very often in 30 years are key to some of our important technology. And perhaps you've heard of some of the important developments in cryptography and quantum computing and so on. And this is, I just highlighted here something as a physicist, which I find still very remarkable, that quantum mechanics, which you learn as a very abstract and even some ways non-intuitive framework, which governs nature at the smallest scales, that perhaps contributes, this is an estimate that many people have made, to between 1/3 to a half of the US GDP. And if that fraction surprises you, I've just listed various things that use intrinsically quantum phenomena, like fiber optics, which involves the principle of the laser, the GPS systems. This is the first atomic clock, which actually the first GPS systems in the 70s were built around this. Transistors, which use, of course, semiconductors. MRI uses magnetic resonance and the photoelectric effect in all our digital screens, and so on. I mean, I could give many more examples, but quantum mechanics, which is a very abstract framework, translates into these very tangible things which people are not even often aware of, but wouldn't have happened if we didn't have the discoveries in the 1920s, so on, in quantum mechanics. So again, these science hubs play that important role of often transmitting that knowledge of the abstract, and people sort of try to then think of how they can build on it and do concrete things. So it's very important to bring together the abstract and the concrete in the same, under the same roof, so to say. So this was a way to try to motivate this notion of the science hubs, and the International Center for Theoretical Sciences that I'm at, which is a new center of TIFR, has been set up in Bangalore to realize such a goal in India. And I think this is an ingredient that can help, at least in this catalytic sense, to seed excellence, to be a sort of an effective hub which will which can seed excellence. This logo of ICTS, just to explain what this behold is, this is actually a proof of the Pythagoras theorem, the what is in a way wrongly attributed to Pythagoras, but the theorem we have all studied on the squares. But this is a visual proof given by Bhaskara, the second mathematician an Indian mathematician who was born not far from Bangalore in the 10th century. And the legend is that he just drew this figure and wrote, "Behold." So because once you see this figure, the proof, in a sense, it's a few lines to work it out. So you see that the a square plus b square is equal to c square. So anyhow, this the logo and the behold. So the ICTS is patterned on the institutions that I mentioned, like the IAS Princeton, the KITP, and so on, but with very significant innovations also tailored to the Indian context, which make it in many ways unique. And I'll tell you a little bit about it. So one of the very heartening things is that it has received a lot of international, there's a sort of an upswell of goodwill for ICTS from the international scientific community in physics and mathematics and computer science. So we have a very distinguished advisory board, and they are not just sort of there for decoration. They are a very committed and involved advisory board, which keeps coming back and to ICTS, and it's very hands-on in their involvement. It has Nobel Laureates. It has so the chair, David Gross, who was my advisor, is the chairperson of the advisory board. But we have a couple of Fields medalists. Manjul Bhargava, perhaps you might recognize from Princeton, the only Indian origin Fields medalist. And Michael Athiya is one of the legendary mathematicians. Similarly, the Abel Prize, the only Indian to be a recipient is Professor Varadhan, and several Breakthrough Prize laureates. So these are some of the cream of world science, and it's very heartening to have their support for ICTS, and I think that that involvement is what is key to recreating the environment at ICTS, which would be similar to what is there at IAS Princeton or some of the other institutions I mentioned. The ICTS mandate is sort of a unique one in that it integrates research, and the research is across many disciplines, together with global programs which bring in world science. That's why we call it the International Center. So the best of world science. And it's both of these are integrated with the outreach that we do for for science in India, and supporting it are the highest international standards, as sort of which our International Advisory Board sort of lays down, and together with what we are hoping to build a strong financial foundation on which an international center like this has to be built on. So let me just say very briefly what differentiates ICTS not only from other scientific institutions in India, but also even some of the places like IAS Princeton, because it's this unique combination of these three elements, this research, programs, and outreach, and I'll just flesh a little bit of these out. So the research is, of course, we have been hiring some of the very top Indian scientists who are returning to India, but the unique thing is that we take this decompartmentalizing very seriously. So we don't even have maths or physics departments. We have people who are ICTS faculty, and they are encouraged to talk. They are sort of not segregated in according to their research interests or anything like that. So that's one of the ways in which our research differs. We curate very special programs. As I said, knowledge curation is a role that these science hubs play very importantly. So we curate special programs on frontier research areas, but especially in those in which India needs to build capacity. There are again tons of exciting topics in science at the frontier, but many of them there's little or no participation from India. So to change that, you need to train younger people. You need to expose the Indian community. So we take these programs very seriously. And at the same time, if I talked of differentiation, I have to also talk of integration. So, this is a vehicle in which India effectively gets integrated into world science. So it's a venue for researchers from India and abroad to spend long periods in collaborative projects. And one of the things which we try to emphasize is also to link with R&D outside academia. I mentioned earlier the lack of knowledge pipelines between industry, R&D, and academia. So to ensure this knowledge flow, it's very important to have these linkages, and in acting like a science hub, you need to we are inclusive in many ways, so we sort of try to bring together the various institutions, of course in Bangalore, but also around India. So to do the science aggregation, that's what you need to do. So it's sort of built a certain synergy, I think, amongst the different institutions, which in a way you had little communication otherwise, but having a node like ICTS brings together people in a more effective way. So that's in our research. I just point out a couple of things that you might be happy to hear about in terms of our research. So the gravitational wave detection by the LIGO observatory in a way was a very epochal discovery, because it sort of opened out a new window onto the universe for the first time. We have been always seeing the universe, stars, galaxies in the wavelengths of light, but this gravitational waves are something completely different. And the ICTS team played a very key role in deciphering this data and understanding the masses and the spins of the black holes. So much so that we got even highlighted in a journal which normally scientists don't usually publish in, but so this was the ICTS team here was one of the people who got the 2015 Breakthrough Prize as part of the LIGO collaboration, and some of these are just bright graduate students who sort of had been just on this for a year or so, and the LIGO fast-tracked them into the collaboration because of their contributions. Something else which is very innovative and illustrates, I think, the importance of decompartmentalization is what I call cloud computing, because it's actually about the Indian monsoon, and which, as you know, is scientifically a very challenging problem. So but it's also something, of course, very critical to the Indian economy, and I think many of the conventional approaches have failed in trying to make good predictive models of the Indian monsoon. So in a way, in a very spontaneous way, several of our ICTS members, which had people from an engineering background, a physics background, mathematics, computer science background, came together to address this they said, let's not do the sort of things that the meteorologists or the climate scientists do. Let's approach this problem in a very different way. And quite remarkably, and just in the span of, and this is of course an ongoing thing, but just in the last year, they have sort of been looking at the monsoon through sort of a two-pronged approach. One is a data-driven approach, which uses 110 years of rainfall data that have been measured in India to extract patterns. And remarkably enough, they fall into sort of, these are the 10 patterns in which they find that all the data of 110 years for each day of the rainy season, you can't see them very well, but they are supposed to be color-coded patterns of the intensity of rainfall in different parts of India, which so in a way, you can see that when there's high rainfall there, that's usually correlated with something else here, and so on. It fits into 10 different patterns, and then they apply ideas from probability on how one pattern transitions to another as a way to try to have a predictive model of not only how much rain there will be in a whole season, but how it will vary from month to month, which is something very important for even farmers to know when to plant crops and so on. So the spatial temporal variation of the monsoon is something that is still an unsolved problem, which will hopefully be addressed by this kind of techniques. And the other, the dual side starts really with doing computations on the physics of clouds, which play an important role in the monsoon dynamics. And so this is where, again, the engineers and the physicists come in with their understanding of, and the flow in clouds is very non-trivial from a fluid dynamics point of view. And it uses extensively high performance computing, so this is the reason for the title. But that's just to illustrate how very concrete problems can be tackled with very abstract one can bring a lot of expertise in different disciplines to tackle a very important, but at the same time, scientifically also very exciting problem. In terms of the programs that we organize, this is, as I said, where Indian science engages with the best of world science. So we gather the top researchers in any subject to come together to sort of ignite these chemical reactions. These are just a sample of various, way back in 2011, we had a program on big data and scientific discovery through big data. These are things about, in chemistry and physics, about technologies of the future. Maybe you haven't heard of laser plasma acceleration, but it's potentially one of those technologies which 10 years from now, doctors might be, or 15 years from now, doctors may be having on tabletops instead of having big proton accelerators for cancer therapy. But so the idea is to make accelerators which fit on your tabletop using novel ideas in laser plasma acceleration. It's something which the US, Japan, and Europe are following up, but in India there's hardly any presence, so we've been catalyzing that activity. And similarly, something in machine learning which brings together, as I said earlier, physicists, neuroscientists, and so on. And we have courses we have a pedagogical component also. When all these experts come here, we get them to also sort of have mini courses for younger Indian researchers. And all our talks are archived on our YouTube channel, ICTS Talks, which has a wealth of material. So in terms of programs, that's one of the things. And as I said, in outreach, we do a number of different events, and this Copy with Curiosity is a monthly sort of a outreach event which has been wildly successful in Bangalore. We hold it at the planetarium, and we get international as well as national researchers to talk about subjects from life in a jar and about mathematics and again the monsoon and the ISRO and so on. It's a whole canvas, and it has now a steady following in Bangalore. And this year we are planning to have a sort of a science festival in Bangalore, like the Jaipur Literary Festival, to create a buzz. We were very heartened when Kip Thorne, who got the Nobel Prize last year in 2017 for Gravitational Waves, he came to ICTS, and we had this sort of rock concert, even because you might know him, he was the person behind Interstellar. And so people came from Pune and so on to attend this talk. So there's a lot of enthusiasm for science, and we want to capitalize on that. So just to wrap up, I think at ICTS there's the right kind of environment which can nurture, I think, Nobel laureates, Fields medalists, and so on, and seed this, at least act as a seed for the systematic excellence which can lead to breakthroughs in Indian science. but we need to build on the to have this in an internationally competitive way requires strong financial foundations, and this is something that we are actively trying to work on. Just to give you a sort of a sense, the IIS Princeton works on a 750 million endowment, which is what allows them to sort of get the world's best people for a small institution of its size. And this is something where in some ways a relatively small investment can act as an accelerator to amplify the effects. So there are various things in terms of an ICTS endowment that we are building in terms of chaired professorships to accelerate new research initiatives, to get undergraduates into research in year-long programs, and also for involvement through our public lectures and Copy with Curiosity. So in a way, I feel that I'd like to sort of see a movement both within India, and we are doing a lot in India as well to generate a certain sense of excitement about trying to make India this global powerhouse of ideas. But I think it also needs active engagement from the diaspora, and I think there are a number of ways, and I'm happy to talk with people about it intellectually in terms of engaging with ICTS, especially many of you are in corporate R&D, and the kind of programs that we organize are a very good meeting ground for academia and R&D to come together, of course, through financial resources, but through social networking and intellectually for those in academia. So ICTS, in a sense, is a vehicle, I think, for active involvement, and I think it's an opportunity to sort of become a friend of ICTS, and I think you can make an impact, and various people are already playing a role. I just want to end with a small video by where you see Manjul Bhargava, the Fields medalist.
ICTS is a young and remarkable institution which is already conducting fantastic research across a range of scientific disciplines, from physics and biology to climate science and mathematics. It's been wonderful spending the year here at ICTS in its very stimulating environment and with its outstanding facilities and infrastructure and, of course, people. I hope to be back many times, hopefully on a regular basis, so that I can pursue some of my mathematical research here with collaborators and with students. I hope ICTS continues to grow and to reach new heights, because it truly is an asset to India and to Indian science and to global science.
So, I mean, I think a Fields medalist like him in India can really catalyze change, and I'm very happy that he spent the last year, a large fraction of it, at ICTS, taking sabbatical from Princeton, and in coming years he plans to spend several months a year, and that's the kind of thing that we would like to get more of, the best of the world, and presence of a Fields medalist as a role model is what Indian science needs to get more of these high achievers. So I'll end with that, and thank you very much for your attention, and sorry for having gone over time. Yeah, a very important question. So the question, just to repeat, was how is one trying to identify, recruit, and the best people who can help to, who will be the future Nobel laureates. And once again, I think excellence follows an environment. When one creates an environment, it starts making ripples, and of course one actively, at ICTS, we actively go out to get some of the best people. So we have people with their PhDs from Harvard and Stanford. Some of our faculty have been at the best places, at Stanford, at Berkeley, at Harvard, at Princeton, and so on. So, and at Caltech, they've trained at the best places. They know what is the cutting edge, and they're contributing to it. They should feel the confidence that they can come back to India and also continue to do it at the level at which they've been doing in their graduate studies or afterwards. And that's the confidence, I think, that we are beginning to give in some of the people, and I'm really happy with the young faculty we have recruited. They are coming back, and again because we've had support from various foundations and so on, we are able to give them incentives and also the flexibility they need, which the usual government system doesn't always allow that. So in recruiting the best people, you need to give them that feeling that they will not lack for the kind of resources and the support, institutional support, which they need for this. They are not going to be sort of caught in some bureaucratic, so it's all this is part of creating that right environment, and we are taking the best practices from the best institutions, and that's what our advisory board helps us in doing, so that we can address precisely that.
As you have been alluding quite often, that it's the critical mass, number of people, number of scientists.
Yeah.
What is the number of faculty there? How many researchers, PhDs, postdocs?
Yes.
And PhD candidates are in ICTS.
So I'll answer.
And I have second follow-up question,
Sure.
independent one.
First I should mention that ICTS is not just about the numbers of its permanent faculty, which I'll just mention to you, but like IIS Princeton, which has about 15 permanent faculty, and it has maybe 20 or 30 visitors at any time, and there's a constant churning through its programs. So we also are patterned in a similar way. We have about 20 faculty and about 60 graduate students and about 40 postdocs, but at any given time in the year we have about 100 visitors, and these are not the same visitors. They keep changing. There are visitors from India, visitors from abroad. Roughly about 1/3 of the visitors are at any given time are from outside India, and these are experts in the topics that we are having programs in. So at any given time there's a large churning of these visitors. So there are a large number of associates who come and spend extended periods of time at ICTS. So in that sense it's like an aggregator, and the Indian science community, almost everyone in the areas of physics and mathematics has come through ICTS and spent a significant amount of time. So there are about maybe 2,000 researchers who come in a given year to ICTS. So that's to give you a sense of the numbers of people. But it's more than just the faculty, because you're acting as a sort of a hub.
But the researchers are the
researchers are
anyway,
about 100, but
question.
2,000 as over a year.
Second question is, what is the status of gravitational wave detector? I understand India is interested in building one like LIGO.
Yeah, in fact, it is a part of the LIGO. That will be the third detector. LIGO has 2 detectors in the US, in Washington State and in Louisiana State. But the third detector will be placed in India. That's very important to understand the physics of to pinpoint where in the sky we are getting the signals from these gravitational waves. So it's a very important mission. And I think this is why I mentioned LIGO in my slide earlier. It's a foresight of the Indian community that it had done the spade work. There was a community of people who were contributing. When the LIGO made its detection, India could immediately announce that it was going to go ahead and place this detector, because it had several years of spade work had been done before that. And now the announcement was made in 2015, and I think the sites have been identified and the construction is going to begin very soon. It will be operational by 2024 or so. It takes a long time because it involves high precision engineering and so on. So it's a major national challenge, and I think to gear up to that, we need to develop a lot more capacity. At ICTS, we have been running a number of schools. In fact, maybe from next week, there's a school on gravitational wave astronomy. So we're building capacity in the country to be able to take on such a huge scientific and technological challenge. It's going to be in near Nanded in Maharashtra. It's in a very barren, it has to be seismically stable, very isolated location.
Thanks, Rajesh, for the wonderful presentation. You have modeled this around IIS Princeton. How important is Princeton in that IIS model?
I'm glad you asked that question. In fact, nothing, I mean, IIS Princeton cannot function in a vacuum. And the Princeton University being, I mean, I studied at the university, but I used to interact with people at the institute. There's a very close connect, there's a very close tie. They're not institutionally, they are independent institutions. They have nothing to do with each other. Some faculty are have joint appointments, but that's all. But that presence is very important. And I think in Bangalore, all the other scientific institutions, especially IISc, play that role vis-a-vis ICTS. IISc is an institution with which we have a very close interaction. Many of our students take courses there. Many of the IISc researchers have joint positions here. So the fact that there is IISc, and not only IISc, several other very good institutions individually in that vicinity is what adds to that ecosystem. So I think we provide a missing ingredient in that ecosystem, which has already developed over some time, but by able to aggregate that excellence at ICTS.
I'm KRS Murthy. Excellent presentation.
Thank you.
There is a saying called Vinaya Vidyakya Bhushana. That's what I see in you. Thank you a lot. If you talk about physics and Nobel Prize, these are the areas: dark energy, dark matter, particle physics, QFT, quantum chromodynamics, etc. These are the areas. Which are the areas that has potential for a Nobel Prize only I'm talking about, not other fundamental development, and that you see that can be done in India? So other than building a satellite or a spacecraft,
right, which of course is more a technological development. But so gravitational waves, I think, really open out a new, as I said, window onto the universe. We are seeing things. The first gravitational wave detection was seeing a phenomenon which you would not have seen with any kind of other astronomical observation. And it's telling you a lot about the early universe. So cosmology, in physics at least, cosmology, gravitational wave astronomy, these are going to, I think, uncover new phenomena which will lead to Nobel Prizes, and that's why the LIGO India, once it's built, and one can, there's a whole, what people are calling a new era of astronomy is beginning, and so that is likely definitely to bring in materials, again, I think new exotic materials, and this is where a lot of contribution of theoretical physicists have also come in understanding the, I mean, graphene was one example, but after that there have been a whole slew of things called topological insulators and topological superconductors, and some of these ideas of topology actually come from the most abstract parts of mathematics as well as theoretical physics. But they are playing a very concrete role in building materials which can have very robust properties like superconductivity and so on, which will not get destroyed. People are trying to use some of these ideas to build quantum computers which will have a robustness and which is protected by topology. So these are just a few, and I'll be happy to talk about more later.
Hi, this is Satish Kulkarni. Thank you for a very insightful talk. So let's go back 75 years in Kolkata.
Okay.
And when there was hardly any science infrastructure, seminal contributions were made in physics.
Right.
I think you know that.
Yes.
Jagdish Bose, Satyen Bose, Meghnad Shah, even C.V. Raman was in Calcutta. So the question I have is that what has changed when there was no science infrastructure? So many contributions were made, and when you are spending thousands of crores, not much is happening in India. And secondly, I like the idea of your science aggregation, which I would call as team science. And so that is how Lawrence Berkeley Lab and UC Berkeley work together. and SLAC and Stanford University work together. And in fact, Lawrence Berkeley Lab is operated by UC's University of California, and SLAC is operated by Stanford University. Such a model is lacking in India. So what do you think?
So to answer your first question about Calcutta and pre-independence science, I think these are difficult questions, historical questions to answer, but two things I would just respond. One is, firstly, there was a certain change in, I think there was a certain mental also a confidence and an ambition to do something which was driven in the pre-independence days to assert the fact that, you know, Indians are no less than Britishers or anyone else in contributing to science. There was a feeling to that is often absent now, I would say, psychologically, and this is where I mentioned lack of confidence and ambition in one of the slides. But the second point is also that science has also changed in character quite a bit since 75 years, in the sense that a lot of the discoveries now are firstly heavily dependent on sophisticated technology. You rarely find the kind of tabletop discoveries that C.V. Raman could make, in theoretical physics, 1920s was a time when a lot of the revolutionary developments in physics were happening. So there was certain ferment there. So the science is not quite the same, and I think I would say there are sort of rare events, this black swan-like events, but maybe aided by some historical circumstances. But you cannot, I think, hope to recreate that because the world has moved on, science has moved on, India has moved on. Okay. So, and then the second question about the institutional collaborations. Yes, so this is why precisely ICTS is one of the... we do a lot of institutional collaboration with places like IISc, like I mentioned, and experimentally also there are examples in India where there are joint experimental and institutions are involved in running some big experiments. Like the biggest radio telescope in the world is run by TIFR out of Pune, and it's called the GMRT, and it is an international facility. About half the telescope time is used by international astronomers, but it's run out of Pune, and TIFR is it's a center of TIFR like ICTS. It's called the National Center for Radio Astronomy. So there are many examples like that. LIGO India will be also a similar example once it is built. There's an Indian Neutrino Observatory. So there are similar examples of the Lawrence Berkeley Laboratory and SLAC in India as well, on a smaller and not yet as successful scale. But on the theoretical front, I think this sort of aggregation is happening through centers like ICTS.
My name is Naresh Batra, and first a comment. One of the things that exists in this country, you already mentioned the amount of R&D. Second is the problem solving and the challenges. And let's be assured that a lot of Indians today throughout the US are contributing a great amount of research in this country. One thing you did not mention, a perfect example, is one of the Nobel laureates is Dr. Hargobind Khorana. When he won the Nobel Prize, he was already a US citizen.
Right.
Okay.
So that's why in my list, I purposely didn't include Chandrasekhar, Khorana, Venkata Ramakrishnan, all these people who did their Nobel Prize winning work outside India. Right. So it's not, so I was addressing the limited question of why Indians working in India are unable, or India as a country, its system, why it's unable to generate the same kind of breakthroughs.
Let me get to the real next question and comment. You mentioned 4 key things such as quantum mechanics, MRI, transistor. But today, the next so-called the Internet 4.0, which is resulting in the 4th industrial revolution, is the digital transformation being driven by Internet 4.0. And that's what's resulting totally, it's going to change the way we work, conduct, and we share the knowledge. And digital transformation is occurring in the form of AI, machine learning, deep learning.
Right.
It's also resulting in so-called IoT, connecting the whole world. And the third element is the blockchain, which is the next wave of the new operating system. Somehow you didn't mention that.
I tangentially touched on machine learning, but I didn't talk about all the aspects. But I think when I said, of course, I didn't have the time to go into all the different areas, but when I said about mathematics and computer science, it's I was alluding to this. It's the internet and many of the things owe its existence to fundamental developments in mathematics and computer science, and that will only continue. But at the same time, I should also add that without physics, the realization of many of these things in terms of its physical hardware and physical things would not be possible without our understanding of basic physics, and the continuing development of new materials and the miniaturization and perhaps even a jump to quantum computation. These will be also underlying the kind of revolution that you talked about, which so it's all linked. That's why the physics, the mathematics, the biology even, all of them have to come together at some way. These are just separations we make artificially, but to sort of the next new scientific, this thing will involve several such areas coming together.
So I know we are kind of running out of time, so we'll just take 3 more questions, and I request that you keep the questions short, and I hope that Rajesh can stay around to answer additional questions after that. So,
a question: what percentage of your budget is government funded, and what percentage is private? And if you had to double the capacity, would you seek more from private?
So at the moment, TIFR, of which so we get our funding as part of the Tata Institute for Fundamental Research. But despite its name, Tata, it's a completely government-funded institution. But some of the special programs that we run, which enable us to get some of the world's best scientists over as visiting professors, we wouldn't have been able to do that without some of the private support, which we are getting at the moment in the form of grants, which are for fixed tenure grants from foundations in India as well as foundations abroad, like the Simons Foundation in the US. I think ICTS is one of the few organizations that have an international. They mostly fund basic research in the US and North America, but they have a few for targeted grants for institutions across the world, and ICTS is one of them, which received one of these special grants. In India, we have also had support from the Infosys Foundation, and the Airbus Foundation also collaborated in some of the work in fluid dynamics. They contributed to that. But your broader question of to really, I say that government funding is like dal roti chawal. It's basic funding which gets you some way, but if you want to do something at the international level, you cannot do it purely within the strictures of government funding. And this is where I think the private involvement is something we are looking to in building an endowment which will help us to do this. To have someone like Manjul Bhargava, who is at Princeton, come and spend several months of the year would not be possible with government funding. And we want not just one example like Manjul, we want some of the best people, and not only of Indian origin, but people willing to come and spend long periods at ICTS because they see that it has the right environment where they can. A lot of people love India and love to come and spend time, but they need that scientific environment to do that. And so to bring that about, you really need the private support, and that's what even not just doubling our size, even with we have, I think, a wide canvas. So with the right kind of support, I think the sky is the limit.
Thanks a lot for a wonderful lecture. Related to the previous question, can you please provide a bit more details on like what are the challenges on funding side, especially from the private sector?
So the challenges in the sense that the main challenge is to communicate the importance of investing in basic sciences, which is people often see that because it's not an investment for which you would immediately see something dramatic has changed in the world around you. Sometimes it might, perhaps in this monsoon project, we might see something dramatic happening in a time scale of 5 years or 10 years. But many other topics, it's a long-term investment and it's building capacity in the country. It is. Otherwise, you're doomed to be a follower. If you're only going to borrow the basic science, and then you're only going to get the leftovers. Someone else will be leading the development and you will be just running, playing catch. But it's important. So one of the things is to try to convince the private investment that this is important for the long-term health of Indian science, Indian economy, and everything. And you draw in a lot of young people also. Some of the best people are stimulated by the basic science questions. So you actually get them more into research questions, which can be afterwards in technology and other things. So in a way, you're able to attract very good people into the cutting edge questions if you invest heavily in basic science. So yeah, that's the message we try to get across, but it's a challenge.
Krishna Saraswat from Stanford University. So it's okay to develop a place where you can aggregate people, but where will the people come from? India's situation in higher education is dwindling. India produces 1,000 PhDs in science and technology per year.
Sure.
Versus China, which produces 25,000 PhDs per year. So if you don't have
I completely agree. I mean, that's a systemic thing that has to be addressed. But what I would try to, where maybe my emphasis would be that if we wait for that to happen, well, we'll wait. And I'm not sure it may happen, it may not happen. But it requires the collective change in the country. But I would just point out, like, even the IITs, let's say in the time when Jay and I went, we had 300 people in our year 5, maybe 5,000, 2,000 people joined the IITs every year in 1987. For a country of nearly 1 billion people at that time. But still, that had an impact. So even though those numbers are very small in some absolute sense, but by concentrating that, the IITs, I think, did that job of at least making sure the excellent people could, there was an environment where they could develop their talents, be trained, and then contribute to India or the world in general, whether it's in India or in the US or anywhere. And I think so. While we need to fix that, and just like we need to have more higher education institutions, which will obviously increase the pool, but even with the limited pool, you want them to be able to perform at a high level. So how do you bring that about? So in a way, what I'm proposing is a immediate pathway, as opposed to something which depends on a lot of factors outside certainly my control. So that's the attitude.
Thank you, Rajesh. Sorry, we're running out of time, so I hope Rajesh can stick around for a little bit more time to meet with you individually. And it's really great to see a lot of passion and energy, and seeing that all of you guys are interested in this. Rajesh, if they want to be associated with this effort, and what's the best way for them to maybe get in touch with you and be involved with this?
So thank you, Jay, for pointing that out. So at ICTS, as we would definitely like people's involvement in various ways. There are some brochures and other things about ICTS at the back of the this thing, which gives some of the things that we would like involvement in. But very concretely, I would say there's you can get involved in anything if you're passionate about, say, science education or science communication. That's something we do a lot of, and if you would like to support some of our science communication efforts, that's something where you can concretely contribute to, both in terms financially or in terms of organizing activities there through your contacts. If you are in corporate R&D, you can I think ICTS provides the venue. I didn't have time to talk about all our infrastructure, but we are geared for, as a venue, we are geared to have meetings which can bring together people so participants from industry and academia to sort of have problems posed from both sides, so that academia gets an idea of the problems that industry wants solved, and industry gets an idea of what are the cutting edge questions in science. So these kinds of programs are things we if you would like to be involved in the organization of these, especially from the corporate sector, we welcome that. And then, of course, we have a number of fellowships and institute chair professorships to get people like Manjul Bhargava and other Nobel laureates to India to spend time interacting with people, because that's the best way in which Indians will be able to feel that they have the access to the best ideas. They can function on equal terms with some of the best scientists and collaborate with them. So this is something I think we would definitely we would need the financial involvement of people to bring that about. And there are others which I can talk to people privately about.
Thank you. Let's give him another round of applause.